Welcome back to our lessons on electrochemical cells. Did you know that aluminium is the most common metal in the Earth's crust? Did you also know that aluminium used to be considered more precious than gold? Surprised? Well, redox can explain all this. Aluminium is a very reactive metal when compared with the other metals we know. Lead, copper, and silver are relatively non-reactive. We even find them as elements in nature. Because aluminium is such a good reducing agent, it's always found as aluminium 3+ ions in nature. It also turns out that it's very difficult to reduce it back to aluminium metal because those 3 electrons can't simply be put back on. Some metals can be reduced in a solution of water, but aluminium 3+ ions are very poor oxidizing agents and water reacts in place of them, making hydrogen. Aluminium ions cannot be reduced by water acting as the reducing agent. So the only thing to do is find the aluminium salt called alumina. It's actually aluminium oxide and we need to melt it to do electrolysis. The major problem is that aluminium oxide has a melting temperature of 2000 degrees. That's higher than steel. So some clever scientists figured out that you can melt another salt and use that to dissolve the aluminium oxide. That salt is called cryolite and has the formula of Na3Alf6. It makes the temperature of the process 950 degrees, and that is hot, but still possible. The aluminium oxide used in the process is called alumina in industry. Originally, it's refined from a mineral called bauxite that is found in large quantities in Australia and Russia. When bauxite is treated, cleaned, and processed, it is pure enough to be mostly alumina and can be used. Now, on to the electrochemistry. Here's the tough part. This is an electrolytic reaction that takes place in a molten salt. So we can't actually use the table of standard electrode potential to figure it out. Luckily, the reactions are not too difficult. The aluminium 3+ is attracted to the cathode at the bottom because the cathode is negative. There, aluminium 3+ plus 3 electrons turn into molten aluminium metal. Not too tough. The oxide ions are attracted to the carbon anodes in the top of the cell, and the positive anode pulls off the electrons from the oxygen to make oxygen gas. You might have noticed that oxygen isn't diatomic, so we need to fix that. Now, balance the atoms. Now, balance the charges to make it 2 oxide ions forming an oxygen molecule and 4 electrons. Now, that's not all. The oxygen is formed at very high temperatures on the surface of a carbon rod. That means that a second very important reaction happens. The carbon anode actually burns. The product is carbon dioxide, meaning that the anode has to be replaced as it burnt away. The aluminium process is not considered to be environmentally friendly because the mining of bauxite uses a great deal of energy, as does the electricity for the process. Roughly 10% of South Africa's energy is used in aluminium refining in Richards Bay, although that is reducing in the near future. The production of carbon dioxide at the anode is also problematic because CO2 is a greenhouse gas contributing to global climate change. Luckily, aluminium is easily recycled and makes 95% less greenhouse gas when used the second time.